Okay, guys, thank you very much. So, let me start the demo by just first walking through the topology. So, what is the physical topology? So, we have four switches. These are four Arista switches. Uh, those two are spine, these are the leaves, and server is hanging off those devices. There is layer 2 on the south of the leaf devices. So, this is all layer 2, and this is all layer 3. And if I go on, say, let's assume on leaf one, I'll show you show LLDP neighbor. You're gonna see the server is hanging of the ET18. And if I go ET1 and 2, you're gonna see these are the layer 3 interfaces. ET2, make sense?
Okay. It does.
So So this is our topology. Uh, all those devices are configured to talk to the CVX, which is Cloud Vision Exchange, which acts more as a controller. So based on the OpenStack requirements for configuration, it just pushes the configuration and configure those VLAN devices so that the VMs can talk to each other. So the VMs can talk to each other, and that's what I'm going to show you. So what I did to start with, I created three environments. So let's assume this is a three-tier application with a web application and database. I created that environment. It's already created. And what I'm going to do, I will add this one just for demonstration. Let's go back and see what I did. So if I go to the compute, you're going to see the instances. So you're going to see the data C, data B, data. So these are the exactly servers. So treat it as more you have a project where you have to create two web servers, uh, three application servers, three database servers, all sitting in separate VLANs and separate subnets. That's exactly what I did. So I created those VMs first, and for example, let's say I add one more to webd. Let's assume I want to add one more webd just to show you an example. It's pretty straightforward. Nova, I will say instance name webd. I will say flavor. These are more the options when you build. Those options will be available to you, and then you're gonna be selecting boot from the image, and this is the only image available. This is more shorter version of the Unix, and I can launch. And now what I have to do is I have to add this to a network. Which network it belongs to is asking. It's belong to network A, B, so it belongs to network web. So now I have one more application coming up. Let's go to the network topology. It also shows you a diagram too, where it is showing three different environments. So it's showing the environments. These are three environments. Let me do the toggle labels. Okay, so this is the web environment, this is a database environment, and this is an application environment. So application A, B, C, all three. So these are three VLANs and connecting through a router. So I have a router too. I created a router, which is a core router, and it's connecting to all three networks. So if you see its interfaces, it has three connections to all those networks. So everything, whatever I'm doing here, and it's reflected over here. So if I go to the CVX, so me go back to the diagram. So what exactly I did, I created few VMs, and those are exactly shown here how those are created. So application A, application C, database B, database. If I go on the CVX, show OpenStack VMs. So these are the VMs created on those servers. So this Kilo is a physical server, and app 1 is created here. App A is created here. App C is created here. This is the app C I just created, so you will not see. App B is created on Kilo 2. So this more shows where how the physical server to the VM relationship exists. This is more of visibility. So let's make it a little bit interesting, because right now everything is configured. This environment is working fine, and now we our requirements come up. We need another environment, which is a management environment, and we need three servers with this network, and they should be able to talk all of these three. Let's create that. So I go back. The first thing I have to do, I have to create a network. So which network so the network, if you see, it's 444 and gateway is 44. So I will create a network. I will say network MNG. Before going to that, I just want to show you on the OpenStack, on the CBX, show OpenStack network. You will see net A, net data, and net web. Make sense?
Mm-hmm.
So now I'm creating net MNG and net MNG1. Network address is 44.44.44.0 slash 24, and gateway is 44.44.44.1. Next, and create. So once I created that net management, what's going to happen? It's going to not only show over here, it's going to associate a VLAN and the VNI too. So you see, so on the CBX, which is more a Arista device, whatever you
Now,
do on OpenStack is created over here. So
Nadine,
this, yep,
the VNI, are you the one assigning it, or you know, or
it's
the system
there is a
assign that?
it is automatically assigned that there is a pool. So let me show OpenStack networks. Uh,
The reason why I ask you is that this is a very big environment. We don't want to duplicate the VLAN that we have. So if dynamically assigned,
mm-hmm.
I mean, it might, look, I don't think we'll get the same thing. But you understand where I'm going?
No,
You
no,
know,
no, you don't have to. That's what I'm showing you. So if you see that, so it shows you the VLAN range to the VNI range. It's just gonna pick. You have to define those ranges. So once you define
okay,
those, you can define on the CVX or on the OpenStack. It will pull that.
so pull that. Okay, that's
And
fine then.
and just going back to one more thing I missed that, and I should explain you. As we discussed last time, this demonstration is more when we are using the hardware as a VTAP. So this is one of the architecture we are just talking about. The OpenStack
So
gives
what?
you off
Okay.
the OpenStacks give you option of using this infrastructure as just a IP fabric and terminate the VTAP tunnels on the virtual switch, on the server. So that is one architecture. There could be a mix architecture where some tunnels are terminating on the V switch, some on the physical switch.
Now, based on your recommendation, what will you go with?
Honestly speaking, I will. prefer to talk to the Red Hat guys. What is their experience in the based on the this is really have to be determined by you based on the application requirements, based on the experience of the Red Hat guys who just deal with the open stack. But everything works, but based on their experience, since they do these deployments regularly, they will give you some recommendation whether you should go on the switch as VTAP uh, or the virtual switch. Ideally,
Okay.
if it's ideal, then it's a virtual switch. Usually, ideally, those systems are designed that you just use the fabric more as a transport and terminate everything in the software.
So you know what our layouts are downstairs on 13. So I don't want. What would you recommend if we are doing these on our side because we're going to be dealing with the neutron part of it? I mean, we have to set our side up. What would you recommend for us to do? Do go through vSwitch or go through the VM itself?
So ideally, if it's a green field, it's better to go on the V switch. It just gives you more flexibility. Then you don't have any dependency. So everything is controlled by then the software. Then you use these devices more as IP fabric. So the
Can you elaborate on a greenfield, please?
greenfield is like a brand new environment. I mean, if the applications don't have dependency, in some cases application have dependency. Like if it's if the
So in an already established virtual environment, that would be a brownfield, right?
I should not say that will be, but if you have the ability to move applications to VMs, you can do that. If you create the OpenStack environment on the with the virtual switch and start moving vMotioning or migrating those applications on those VMs, you can do that way too. So I don't know
Right now,
how. Yep.
right now we have VMs, and then we have vSwitch also. So we're using the vMotion, everything like that currently right now.
So to be honest, this is a big decision. There is a lot of work needs to be done on the application level, which is the best strategy to move, what is the best architecture to adopt, and you guys probably should engage the Red Hat OpenStack too. I mean,
Okay.
that's something they do day in day out.
Okay.
You understand? So
We
I
are.
cannot claim no way that I am an OpenStack expert. I can demonstrate show you some part of it, how it will be integrated to Arista and how it will work. But no way I cannot claim that I'm expert on deployment migrations of OpenStack. But
Got
definitely
it.
I can help you. What are the abilities which Arista offers? You can leverage those abilities for your architecture. So once you have those conversation with those guys, you can say that our underlay or physical infrastructure have those capabilities. We can terminate
So,
our VTAP, we can terminate our VXLAN on the physical infrastructure, or we can have a combination of virtual switch and physical, or we can just go to virtual. So it's really more it's a critical decision. Actually, that's the direction you will be going moving forward, pretty much fixed.
okay. So what you just said actually do make sense. What we will do is that we'll invite Red Hat. I mean, we did a open proof of concept about 2 months ago, I believe. So maybe we might need to bring them in,
Yeah,
and you guys also be part of the meeting so we can discuss on how to move on our side.
absolutely. Yeah, absolutely, that's a possibility. But we need I mean, we need to understand their experience too. What is the best strategy that works in their opinion for a similar environment like you? What is better feasible? Because You understand what I'm trying to say? That's what they do.
Oh,
They should be
we
able
understand.
to.
We understand, Nadine. So you can actually proceed, though. We understand.
So in our example, we are creating VLANs and everything over here. So I created a network. You see, it's visible on the CVX. So CVX is so OpenStack dashboard. We are working on. We created a network. You see on the CVX. Now, what I'm gonna do, I'm gonna create a compute instance. So I'm gonna create a compute instance over here, which is this environment. I'm gonna be creating this environment. So I already created network. So now I'm going to create three instances. So three compute instances I'm going to create. Management A, manage A, uh,
Yeah. Just dawned on me. Why do you think that the guy wants us to take over? He wants us to put all that stuff on his statue because he wants us to manage the V switch. So that's on each enclosure. There's a V switch on each enclosure. Correct. You need resources.
MNGB. I created this. I'm going to be image. I'm going to network choose the MN. So
That's
I
specific.
created actually management A and management B, two instances. And if I go there, if I go show OpenStack VMs, you're going to see the management A and management B, those two instances. Make sense? And those are created on kilo 2 and kilo 1. So what this output is showing, you created VMs through OpenStack on those two devices directly. So the Nova will talk directly to those guys, create those VMs. Then you ask CVX that these VMs belong to so and so networks, and it automatically create VLANs, associated VLANs, and provide connectivity. So if you see, those two devices are sitting on kilo 2 and kilo 1, and they should be able to talk to each other.
So the virtual router creates it already adds a route dynamically within within your environment so they can talk between each other.
So in this case, in our demonstration, the OpenStack is asking CVX to create the VLANs and the VXLANs over leaf 1 and leaf 2. Under leaf is a trunk port and there are servers hanging off that. So it's only trunk port. And this is IP fabric. So you know a layer 2 to layer 2 cannot talk over the IP unless we have a VXLAN tunnel. So if you see right
Right.
now, I have opened couple of consoles. So if you see, Apple A is sitting on kilo 1. Apple application A is sitting on kilo 1. Application B is sitting on kilo 2. Make sense?
Okay.
And they
Done.
can ping each other. If I want to ping, if you see that what is the IP address for application A? Application A is 3 and application B is 4. And if I go there, if you see that IP config, IF config. So if you see that, you're gonna find that it's IP address 22.22.3, and this is 4. Make sense?
Mhm.
So A is sitting on kilo 1 and B is sitting on kilo 2. And now if I ping that, let me ping 22.22.22.4. So I'm pinging the 22.22.4. Make sense? So let's go back what happens on the, so if I see the details on the, for application 1, what I see on the application. So application 1 is sitting on kilo 1, application B is sitting on kilo 2. Let's get more information about uh, networks. Okay, so it shows that the application belongs to VLAN 1122 and it maps to 11.12.2, VNI to 11.12.2. And if I go on the leaf, you're gonna see it created actually automatically show sh- show VLANs. If you see those VLANs, 1111, 1122, 1163. If you I go there, what are the VLANs? So VLANs are 22, 18, 63, and 98. 63 and 98. It just created. If I create one more network, it will create one more VLAN. So if you see the latest one, the one we just created is the management one, is 63. So it created a VLAN. And if you want to see the VXLANs, show interface VXLAN 1, it will show you the mapping too. So 1163 is mapped to this VNI, and these are the VTABs. So 334, if you see the uh, show IP interface brief, this is 33 VTAB, and if I go the other one, show IP interface brief, it's this one. So that's one part. So one part is anytime you provision servers, it's gonna automatically create VLANs over here. It's gonna create associated VNI tunnel to connect those two devices. So that's one part. If I go back to the OpenStack diagram and we see the network, how the network topology look like. So
You
right now
okay?
you see the no, I'm good, thank you. So if you see right now, those three environments are connected through a router and they can talk to each other. So let me go on uh, net uh, app one. I'm gonna go on app one and I'm gonna ping database B and database or web A. So any of those. So let me go and show you the instances. So if you see application A, this is where I am, 22.22.3. So this is where I am. Let me just stop this. I'm here on 22.22.3 and I'm gonna ping to another network, let's say 44.444. Let's see whether we have inter-VLAN connectivity or not. And then I'm gonna talk about what exactly happens and why it's talking to that. So it's not talking. So we cannot talk to the management interfaces. So we can still sorry, management VMs. We cannot talk to the management VMs. You see that if you I go back and I show you the topology,
It's not connected.
it's not connected to the router. So no routing is not connecting to these guys. But let me ping to the data and the web. Let's go back and try to ping the one who are connecting to the router. So let's go to the router and what's gonna see. So let's go to the web and I'm gonna ping 11.11.5. Okay. You see, it's the cross. So what exactly is happening on the Arista leaf switches? On the Arista leaf switches, if you see, it created the VLAN interfaces. So the gateways are the VLAN interfaces. So it's like your core switch. Make sense?
Yes.
So routing is happening. So right now you don't see 444. You don't see that. That's the reason it's not happening. Let me go back to the OpenStack and what I'm going to do, I will associate the fourth one to the router. So what I'm going to do on the router, I'm going to pick a core router and I'm going to attach that interface to. So add interface. I'm going to select this one, which was not connected before. Add interface. Now, if you see the topology,
Yeah, it's the same.
so it's connected now to. So if I go on this, the same device, something changes here. Oh yeah, the VLAN interface is created. Make sense?
Does.
So what exactly is happening? Anything you are doing on the GUI interface of OpenStack through the Neutron and APIs, everything is being built in your infrastructure based on your requirements and it's transparent to you. So let's go back to the same and try to ping the 444 this time. We failed last time. You see that? Make sense?
Yeah.
Now it start working. So what exactly is happening? So there are three things actually those were happening. One was anytime you create a network, this CBX has the intelligence and it's going to create a VLAN and the VNI association. It needs VLAN on the south side to associate with the servers, virtual servers, and on the north side for the tunnel, this need a VNI. So these guys know what are the VLANs, VNIs we need to use. Then if I create routing, it's gonna create a VLAN interface too. So the routing start happens and these guys start talking to each other. And this all happens transparently from the OpenStack perspective because you as an OpenStack user, you will be working only on this GUI creating environments and everything whatever happening is abstraction for you. So if you see the networks are there, the and what else, it also shows you the show show LLDP neighbors. So you see that kilo one is connected here. If I go here, I can get all kind of information. So show VMs, it's going to show me all the VMs created, where those are created. If I want to see where the kilo one sits, show up, it's going to show me kilo one sits on, uh, it's a networks. Let me, so it's going to show me the interfaces too. You see that? It's going to show me mappings, interfaces, and everything. So it's gonna show me everything. NetWeb, Kilo One. So Kilo One is sitting here. The show tenants. So if within your organization you have different tenants, you can create that too. So say let's assume you have a HR department. They need to create their own environment. So everything we are building right now is under demo tenant. Tenant is think of more a customer. If you have a finance department, you can create a create a virtual environment for the finance department, and it's all carved out of all those all the compute, storage, and the network, whatever resources are available. Let me go to and see what else is there. Physical network. So this is showing you the physical associations of those. So where the application A is sitting in VLAN, so and so. So you have all this information available, which is more on a physical and logical layer. And Arista switches, if you go to that architecture, is going to build the network for you. Make sense?
Yep.
And that's pretty much it. Was just more an example just to give you a concept. There are a lot of other things you can do with the OpenStack, like you can apply security policies, you can introduce different kind of services, you can introduce routing, all that. But that was a very basic, just more a conceptually, just to what really how it's used and what is the use. You can complicate this environment more and more, that I want between web and application distance this traffic only flow. I want only the web should be able to go to the internet. You understand what I'm trying to say? And you can
Yep.
define policies, and OpenStack gives you all those options to build that. And I think at some stage you have to come up with some kind of write up for all those applications, where you have to define those templates, how you want to create some kind of maybe that could be a good start actually, if you start gathering information about your applications and just know what are the VLANs, any limitations, or the can that service run on a VM, or it has to be a physical server like the old wax servers or something like that. I'm not sure you have any of those crazy big servers, or I mean, some legacy applications only run on physical servers, those kind of things. But I believe this could be a good start if you really have the information about your applications and how those applications have are set up, what are the tiers, how they talk to the environments, what needs to talk, what kind of security you define between those. If you have all this information, that will make your life easier to migrate. And then
Okay.
maybe just migrate one application and then see how it goes.
Okay. So what we're gonna do is that we're gonna engage